Okay, put your worksheet side by side. Let's go into the lesson today. It's still plant parts and how they work together still. Okay, let's go to the first question first. Okay, you have this question. Malcolm wanted to find out. Hang on, let me adjust the screen first. Can see my face or not? Can, right? I cannot see my own video face, but can see my face. Open my own video. Oh, there. Okay. Does it look weird? No, let me switch on the lights, Jarvis. Hang on. Better, right? If not, I think my face look a bit scary, Okay. Anyway, okay, let's go through the first question. You have this guy, Malcolm. Okay, Jarvis, let's go. Let's start. Okay, you have Malcolm wanted to find out which soil would be best to grow a plant. Then he listed some of the steps below. So all they want from you is to rearrange the steps in the correct way. Okay, hang on. Let me open your worksheet and look at your answer that you Okay, your answer you put is B. First, you say is prepare 3 similar pots and put 100 grams of soil into X, Y, and Z. This one sounds like a correct first step to me because the first thing you do is gather 3 pots, correct? Because you have 3 types of soil you want to test. And then after that, you put in the same amount of soil, same amount, because you have already changed one variable at the very beginning already. This is the changed variable. You learn already, right? This thing called change variable in school, right? Okay, so it's time to start using all these words and understanding all this in your answer because primary 5, primary 6, you will keep on having this understanding, okay, this concept being tested throughout even in secondary school, your whole student life, I would say. Okay, so this is your change variable. And the thing about experiments, change variable, only one only. So this must be the only change variable, which is the type of soil. Okay, so the rest must keep constant, therefore 100 grams of soil. B seems correct. Anyway, all the options I realize starts with B. Okay, no issue. It's just the second one, right? The second step. Is it A, E, or C? So let's look at A first. A, they say that place all 3 setups in the open field. But, okay, I think, okay, if you place 3 setups in the open field, right, you are almost done with I feel like you're almost done with the experiment already, correct? You place them in the open field, after that, probably the next thing you're gonna do is just leave it there and let the time for the experiment take place. So I feel like there's something missing in between, right? He wants to know what is best to grow a plant at which soil. So I think he should put in the plant first, correct? So I think the one that is putting the plant inside is E. Place similar seedlings. Again, this variable you must keep constant. Okay, this also constant. I should use the word constant now. Let's change the words to constant here because they are technically known as constant variables now. Okay, so E is correct. A and D automatically out. Your answer was what? B, right? Okay, so it's the next one that you mixed up, is it? C and A. You put C first. Water each pot daily. Whereas A, you place 3 setups. Yeah lah, you place 3 setups first lah, Jervis. Correct or not? Right? You have all the pots already. You have all the soil inside already. You have all the seedlings inside already. You place them outside first. Okay, open field, all same location, constant. Then every day, this word daily means every day, you water them. So the word daily there already tells you that this comes after you put the 3 setups in the field. Because this is done every day, this must be done on the first day of the experiment already. Okay? So just flipping around these two lah. I think just be careful of the arrangement. Double check your answer law. Okay, double check. See whether it makes sense or not. Okay, then after that, D is observe and record. This must be the last one lah. Correct. Okay, so the correct answer here is C. Okay, let's go to the second one. Okay, second one, your answer. Let me take a look at your answer. Second one, you have, what is this? B as your answer, is it? You put B? I think you put B. Yeah. Okay, let's take a look at what's this. Coming set up an experiment to find out if the absence of roots affects the amount of water absorbed. This is the aim of the experiment. Did I tell you last week? Was it last week or was it last week? About what you can actually find in the aim of the experiment. Did I tell you this already? Do you remember, Jervis, if I had told you this already? I did, huh? Okay. What are the two things that you definitely can find in the aim of the experiment? Do you remember? Remember or not, Jervis? Still remember?
The fair test.
No, not fair test. This fair test is about the experiment itself. This one, right, is in the aim. The statement that you see there, I underlined that. In the aim of the experiment, there are two things that you can find out, that you can, two information that you can get from the aim itself only. Do you know what it is? Two types of information. Can or cannot? Cannot. Okay, let's recap that very quickly. You can find the two things that you can find in the aim. Number one is your, what's that thing called? Changed variable. In the aim, you must always talk about a changed variable and a measured variable. Together, you put them together, you tell me how the changed variable affects the measured variable, then that is the aim of the experiment. Okay, so this one is, they say, to find out if the absence of roots. So this must be your change variable. Because if you want to find out about if no roots, will the water be affected? Probably you have a setup with no roots and another setup with roots. Then you can see whether the roots have or don't have, whether the amount of water absorbed will be different or not. Okay, so change variable is this one. And amount of water absorbed, this thing over here, this will be a measured variable of the data, right, that you gather. Okay, so when you freeze it like that, okay, then it becomes the aim. All aim must have this two. So if the question asks you to write out an aim of the experiment, must be something like this. Okay? Okay, which of the following should he use, as the control setup for the experiment? Okay, then you have another word like control setup. Like this one, your teacher got teach you already the word. Got see before, or what? Your teacher got talk about a control setup before. Or is this your first time looking at the word control setup? First time, is it, Jervis? First time, okay. Control setup, right? Every experiment, right, must have a control setup. It's just that sometimes in the question, they won't show you because it's not important to answer the question. Understand? But every experiment, if you're a scientist when you grow up later lah, if you're a scientist, whenever you do an experiment, you must do a control setup. Okay, but not all experiment for now lah, in questions, they will give you lah. But now they give you. Okay, so let's ask ourselves about the purpose of a control setup. So I'm going to write here purpose, question mark. There must be a reason why you do certain things. If not, then you're just wasting money, wasting resources, wasting time to do a control setup. Okay, so in an experiment, if you look at the aim, your aim sounds like you are trying to find out about something, right? About whether a factor affects another process, a certain process, correct or not? So if you carry out an experiment, you do it, you create a setup and then you carry out the experiment, you gather the results. After that, let's say you want to present your results to your friends, to your teachers, to your parents. Okay, you want to say that, let's say we take a look at this aim. Let's say you want to find out if the absence of roots affects the amount of water absorbed. You do the experiment, and then at the end of the day, when you collect the data, you realize, hey, yeah, the absence of roots do affect the amount of water absorbed. Then you want to tell people that roots actually is important about with regards to water absorption. You want to tell them that you want to make a claim. So you present your experiment to people and then you say, look, roots are important for water absorption. But you know what people might say? People might say that, how 100%, are you 100% sure? Are you 110% sure that the water level changes, the amount of water that change over here in your setup is because they are taken in by the roots? You know, the water might just evaporate away, you know? Correct or not? What if someone's pointed out that to you? The water here, okay, here no roots, right? Got plant only, got leaves. Water here, but what if someone tell you that the water might evaporate away, that's why the water level go down? But there you are trying to tell people that, look, no roots means no water absorbed. You know, so you need more solid proof to like tell people that for sure the changes in the water level is because of the root versus no root, instead of other factors like evaporation. Like that. So far, so good or not? Can understand, right? Okay, so that's why you do a control setup. Okay, a control setup's purpose, right, is, let me write on top here, to prove that changes in your measured variable is because of your changed variable and nothing else. Can you see the red parts? Not change variable and not other factors, not other factors. Okay, so it's like you can have another setup to compare. That means, right, you can have another setup with the, what's that thing called? With the root. But then you must make sure that, you know, other factors are not controlling the measured variable that you measure later. Okay, so which one would you choose? Let's take a look at the options. You pick which one? I forgot again. Hang on. Let me go back to your. Is it B? You pick B, is it? You saw your answer, right? B, right? Okay. Okay, B, right? Okay, if you take a look at B, right? B says that you have roots, okay, but then over here you have layer of oil. You are changing two things about the setup, whereas your original setup here, no layer of oil. Correct or not? Don't have. So in an experiment, you only change one variable. B, you change two variables already, so cannot be the case. You must only pick one that is changed one. Okay, B is out because they have two change variables there. C also out because C is no different. Correct or not? C no different. D, okay, these unique, D, they have no roots, but they have a layer of oil. This one is to prevent evaporation of water. Okay, and then if you take a look at A got roots, no oil. Okay, between A and D, right, Jervis? Listen carefully. Between A and D, A will be the one that you compare in the experiment. That means you have this aim that you want to see if the absence of root affects the amount of water. So in the other setup, one no root, one got root. Okay, the control setup then would be this one, D. Okay, because you want to make sure that other factors such as evaporation are not happening to the water. So if let's say any water level, if the water level go down over here, then your what's that